Dear students, in our last Assalamu alaikum. Dear students, in our last topic, in our last lecture, we have studied about types of intermolecular forces and explained dipole-dipole forces. In today's topic, we are going to explain London dispersion forces, which are also known as dispersion forces, instantaneous dipole forces, or induced dipole. These forces was first explained by Fritz London in 1928. These forces are majority present in non-polar molecules like hydrogen, helium, neon, argon, and many others. Among all types of intermolecular forces, these are the weakest type of intermolecular forces. These are short-lived and are of temporary existence. Now come towards its definition and other properties. The force of attraction between non-polar molecules which becomes polar for an instant is called London dispersion forces. Interesting point is this: when non-polar molecules become polar for an instant. How non-polar molecule become polar? Explain it later on. The non-polar substances like hydrogen, helium, neon, argon, fluorine, chlorine, methane, these are non-polar in nature and can be liquefied or solidified under appropriate conditions. Now we are going to look how non-polar molecules become a polar molecule and how it how it can induce dipole. First of all, we are going to consider helium gas. Helium gas gas consists of two electrons, and these two electrons are evenly distributed in spherical region, and so it is unpolarized molecule. In an instant, these two electrons get together at a point, at an edge, and that edge or that corner or that pole becomes partial negative. That got the charge partial negative or slightly negative charge. The other end that is deprived of electrons got partial positive charge. Now it becomes a dipole, but it is instantaneous dipole atom. These instantaneous dipole atoms create a dipole on its neighboring atom, but because of this partial positive sign, this neighboring atom carry all of its electrons in that end, and that end becomes partial negative and the other end becomes partial positive. Because of this instantaneous dipole, it has induced a dipole in its other molecule. In this way, your unpolarized non-polar helium atom becomes instantaneous dipole, and that further induced dipole in its neighboring atoms. This is the way in which non-polar molecules become polar molecule. The next topic is what are the factors which affect London dispersion forces. Some of the factors that affect London dispersion forces are atomic or molecular size, polarizability, number of atoms in a molecule. We will discuss these factors in detail in our next lecture. Thank you.